This video, distributed by Drivetrain Service Division, is just one in a series of training programs available from your drivetrain specialist. For total value in product and services, look for the sign of the specialist and specify SPICER.
SPICER angle spring clutches are made up of four major components: the cover assembly and two driven discs separated by an intermediate plate. These heavy-duty clutches are pull-type dry disc design. They come in either the manually adjusted model or the wear compensating model, which automatically adjusts the clutch for facing wear. In service, mechanical adjustment is required periodically for manually adjusted models. 3 pairs of angle springs are equally spaced around the clutch cover to reduce the pedal effort required when engaging and disengaging the clutch. Because the springs are isolated from the direct heat of the pressure plate and are angled, a constant plate load is ensured. Driven discs are available with organic or ceramic facings. Organic facings are for medium-duty highway use, while the ceramic facings are for heavy-duty highway or off-highway applications. The life of a clutch is increased by using ceramic face driven discs. Driven discs may be furnished with a rigid or dampened type hub. The dampened type is recommended to help absorb shock, control torsional vibration in the drivetrain, and reduce spline wear to the transmission input shaft. In extra heavy-duty applications, coaxial springs are used. Coaxial springs are springs within springs, which additionally reduce shock and control torsional vibration. Major components of a typical 15.5-inch cover assembly with wear compensator are the pressure plate and levers, pressure plate return springs, cover, adjusting ring, pressure springs, release bearing and sleeve assembly, and the wear compensator. 14-inch clutches use a different intermediate plate, pressure plate, and clutch cover. Other components are the same as in the 15.5-inch clutch. Most installations include a clutch brake, which helps the driver shift into first or reverse without transmission-damaging gear clash. However, the clutch brake should not be used for upshifting. There are 2 types of clutch brakes: a single-piece torque-limiting type and the 3-piece design. Clutch brakes are used to ensure smooth shifting and are only activated when the driver pushes the clutch pedal to the floor. We recommend the torque-limiting type because it's designed to slip when heavy loads are reached. This prevents early clutch brake failure. SPICER clutches should be replaced when adjustment cannot correct for a loss of free pedal or cannot compensate for a slipping clutch. When removing the transmission, use a sling or jack to maintain alignment. Don't let the rear of the transmission drop, and don't let the transmission hang unsupported in the spline hub of the driven discs, because it distorts them and could cause poor clutch operation or clutch release problems. Taking these precautions will prevent bending and distortion of the clutch discs and ensures trouble-free performance. Before pulling the transmission free, disconnect the external clutch linkage and turn up the release yoke so it will clear the release bearing when it's removed. Carefully pull the transmission back to remove the spline shaft from the driven discs and the clutch. Install a spline aligning tool in the release bearing and the driven discs. You can use an old transmission input shaft for this purpose. Pull the release bearing back using the release tool shown. Insert 2 5/8-inch spacers between the flywheel ring and the release bearing housing. The spacers relieve the heavy internal spring load of the clutch cover. Completely remove the top 2 bolts and install 2 guide studs. Take out the remaining mounting bolts and carefully remove the clutch. You may want to use a hoist to do this because a 14-inch clutch weighs approximately 75 pounds and a 15.5-inch clutch installation weighs approximately 150 pounds. Now that the clutch has been removed, the following inspections must be made. Inspect the mating surfaces of the transmission clutch housing and the engine flywheel housing. Any appreciable wear on either housing will cause misalignment. Most wear will be found on the lower half of these surfaces, with the most common wear areas between the 3 and 8 o'clock positions. Replace the clutch housing if it's worn. Begin by wiping all surfaces before gauging. Secure a dial indicator to the engine flywheel or crankshaft and put the gauge finger against the housing pilot. Rotate the flywheel or crankshaft. Use a piece of chalk or soapstone to mark the high and low points. The total indicated difference between the high and low points must be 8 thousandths or less. Move the gauge finger to contact the face of the engine flywheel housing. Again, rotate the flywheel or crankshaft and then mark high and low points. The total runout should not exceed 8 thousandths. Next, secure the dial indicator to the engine flywheel housing with the gauge finger on the face of the flywheel near the outer edge. Rotate the flywheel or crankshaft. The maximum permissible runout is 1/2 thousandths per inch of flywheel diameter. For instance, with a 14-inch clutch, the maximum allowable total runout is 7 thousandths. Move the gauge finger to contact the pilot bearing bore surface. Again, rotate the flywheel. The maximum total allowable runout is 1/2 thousandths. If any of these limits are exceeded, the problem must be corrected, or misalignment will cause premature wear to the drivetrain components. Use a piece of chalk or soapstone to mark the present flywheel to crankshaft position. Loosen the bolts, remove the flywheel, and set it on a work surface. Using an Allen wrench, remove 2 set screws from each of the drive pins. Since the drive pins are made of hardened steel and could chip, wear safety glasses when removing the old drive pins. Drive out the old drive pins. Install 6 new drive pins in the previously unused holes in the flywheel. Space them out equally. Make sure that the shanks of the pins are a press fit in the flywheel rim. We recommend that a drive pin aligning tool like the one you see here is used. Make sure that the heads are square with the friction surface. Put 2 small spacers on the friction surface of the flywheel and carefully set the intermediate plate over the drive pins. The spacers will prevent getting your fingers pinched by the intermediate plate and give you a finger hold when removing it. Turn the intermediate plate in one direction as far as it will go. Use a 5 thousandths feeler gauge and check the clearance between the drive pin and the drive slot. Check the same side of each pin. The minimum clearance between the drive pins and the drive slots is 4 to 6 thousandths. If the proper clearance is not obtained, recheck the drive pins for squareness and realign if necessary. Then recheck the clearances. Do not file the drive pin slots on the intermediate plate to obtain correct clearances. Doing so will cause an unequal load on the pins. This is a frequent cause of poor release, or the clutch not releasing at all. It can also result in broken drive pins. If the alignment and clearance are okay, lock the pins in place with 2 new 3/8 inch by 3/8 inch set screws. Reinstall the flywheel to the engine crankshaft, making sure the chalk marks are lined up. Refer to the engine manual for torque specs. Remove the pilot bearing and replace with a new bearing. Caution: tap on the outer race of the pilot bearing only and make sure it's seated properly in the bearing bore. This bearing must have a press fit. Place the front-driven disc against the flywheel with the side-stamped flywheel facing the engine. Next, install the intermediate plate. Position the drive slots onto the drive pins. Caution again: Super Duty clutches have thicker intermediate plates and thinner super buttons than standard clutches. Do not intermix these components. If you are installing a Super Duty clutch, be sure to install 3 anti-rattle springs. Space them equally between the drive pins with the rounded sections toward the flywheel face. For safety reasons, you should wear heavy gloves when installing anti-rattle springs. Insert the aligning tool through the hub of the rear disc with the side-stamped pressure plate facing the transmission, and install it behind the intermediate plate. Remember, it's imperative that the side-stamped pressure plate faces the transmission. Insert the aligning tool through the hub of the front-driven disc and into the pilot bearing. The relative position of the buttons on the front and rear discs is not important. Position the clutch cover over the guide studs previously installed at the top of the flywheel. Make sure that the wear compensator or adjusting lock will be in line with the opening of the bell housing of the transmission. Start 6 3/8 by 1 1/4 inch grade 5 or better mounting bolts with lock washers and tighten them finger tight. Remove the guide studs and replace them with bolts and lock washers. Tighten the bolts in a crisscross sequence to pull the clutch into its proper position in the flywheel pilot. You must start with the lower left-hand bolt. Failure to tighten the bolts in this manner can cause permanent damage to the clutch cover or create an out-of-balance condition. As the bolts are tightened, the wooden spacers should fall out. If they do not fall free, be sure to remove them. To achieve the final torque, progressively tighten all bolts to 30 to 35 foot-pounds. You may have to lightly tap the aligning tool with a mallet to remove it. Installation of the 14-inch clutch is now complete. Reinstallation of the transmission and the adjustment procedure will follow the section for installing 15.5-inch clutches. Rotate the flywheel to level the 2 guide studs which were installed when the old clutch was removed. Insert the aligning tool through the release bearing sleeve in the new clutch. Put the rear-driven disc on the tool with the side-stamped pressure plate facing the pressure plate. Place the intermediate plate in the clutch cover and align the driving lugs of the plate with the slots provided. Install the front disc on the aligning tool with the side-stamped flywheel facing the engine. Remember, it's imperative that the side-stamped flywheel faces the engine, and the relative position of the buttons on the front and rear-driven disc is not important. Make sure that the wear compensator or adjusting lock will be aligned with the opening in the bell housing of the transmission. Position the clutch over the guide studs and slide it forward. A 15.5-inch clutch weighs about 150 pounds, and a hoist may be required to lift it into place. Start 6 7/16 by 2 1/4 inch grade 5 or better mounting bolts with lock washers and tighten them finger tight. Tap the aligning tool to make sure it's centered and seated in the pilot bearing. Remove the guide studs and replace them with bolts and lock washers. Tighten the bolts in a crisscross sequence. Remember, if the bolts are not tightened in sequence, you can cause permanent damage to the clutch cover or create an out-of-balance condition. To achieve the final torque, progressively tighten all bolts to 45 to 50 foot-pounds. You may have to lightly tap on the aligning tool with a mallet to remove it. Installation of the 15.5-inch clutch is now complete, and you're ready to reinstall the transmission to the engine. To reinstall the transmission, shift it into gear. If a clutch brake is used, be sure to install it on the input shaft of the transmission at this time. Check for wear on the fingers of the clutch release yoke. Also check the cross shaft and cross shaft bushings. Replace them if necessary. Make sure that the transmission is square to and aligned with the engine when it's raised into position. Lift the release yoke so that it clears and is rotated over the wear pads of the release bearing as the transmission is moved forward. Be careful. The release yoke fingers must not be elevated to the straight out position. They would damage the clutch cover when moving the transmission forward. Move the transmission forward, but never, and we repeat, never force the transmission into the clutch or flywheel housing. If it doesn't enter freely, investigate the cause and make adjustments until it does. Don't let the rear of the transmission drop or hang unsupported in the driven discs. Mate the transmission with the engine housing and install the mounting bolts. Torque the bolts to the proper manufacturer specifications. Attach the clutch release linkage. Installation of the transmission is complete and adjustments to the clutch can be made. The following adjustment is made by shortening or lengthening the external linkage rod and applies to both the manual adjust and the wear compensating type clutches. Adjust the linkage so that the clutch brake squeeze begins when the clutch pedal is 1 inch above the floorboard or at the end of its stroke. If a clutch brake is not used, internally adjust to obtain approximately 9/16 of an inch between the clutch cover and the release bearing cover when the pedal is fully depressed. Then, adjust the external linkage to obtain the 1/8 inch free pedal dimension. Check the 9/16 inch and the 1/8 inch measurements with the pedal in the up position. To adjust the free pedal on a manual adjust clutch, remove the adjusting lock. Proper adjustment of the free pedal should be approximately 1.5 inches at the top of the stroke. With the clutch pedal completely depressed, rotate the adjusting ring to achieve the 1.5 inches of free pedal. Turning the adjusting ring clockwise moves the release bearing toward the transmission. This increases free pedal. Turning the adjusting ring counterclockwise moves the release bearing toward the engine. This decreases free pedal. Visually check both the free travel and the release travel in the bell housing. The free travel should have approximately 1/8 inch of space between the yoke and wear pad. The release travel, however, should be a minimum of 1/2 inch for the clutch to release properly. Reinstall the adjusting lock to hold the adjusting ring in place. On wear compensating clutches, there should be 1/2 inch release bearing travel for the wear compensator to function. To adjust for this, locate the wear compensating assembly on the clutch cover. Remove the right bolt and loosen the left bolt 1 turn. Rotate the wear compensator upward and tighten the bolt. This will disengage the worm gear from the adjusting ring to allow for manual adjustment of the clutch. With the clutch pedal completely depressed, rotate the adjusting ring by engaging a screwdriver in the lower teeth to achieve approximately 1.5 inches of free pedal. Clockwise adjustment increases free pedal. Counterclockwise adjustment decreases free pedal. After adjusting the free pedal, loosen the left-hand bolt and rotate the wear compensator downward to engage the worm gear with the adjusting ring teeth. The ring may have to be rotated slightly to allow the worm gear to mesh. Install the right bolt. Then, torque both bolts to 30 to 35 foot-pounds. The actuator arm ball should have been inserted into the release sleeve retainer as shown here. If the wear compensating assembly is installed properly, the actuator arm will move back and forth as the clutch pedal is activated. It's important to note that the clutch will not self-adjust if the actuator arm ball is not inserted into the release sleeve retainer or if the release bearing travel is less than 1/2 inch. Most wear compensating clutches use permanently sealed release bearings which never require lubrication. Check to see if your bearing has a grease fitting. If it doesn't, it's permanently sealed. After completing the clutch adjustments, lubricate greasable release bearings with a recommended high-temperature lubricant. See your SPICER service manual for types and manufacturers.
This video, distributed by Drivetrain Service Division, is just one in a series of training programs available from your drivetrain specialist. For total value in product and services, look for the sign of the specialist and specify SPICER.